Welcome to For the Love of Books, a podcast by Lanarkshire Libraries. Hi everyone, welcome back to the Lanarkshire Libraries podcast For the Love of Books. My name is Chris Wilson, the E-Services Librarian, and today I am joined by two very special guests who are members of the Airdrie Astronomical Association, and we've got William Tennant and the chair of the group, Richard Shaw, as well. So welcome guys to the podcast. Thank you for coming along.
Pleased to be here.
Fantastic. And for our listeners who may not know that we've got an observatory in one of our libraries, I'll give you a little kind of quick background on it. There's been an observatory in the Airdrie Library since 1895, which is an unbelievable amount of time to have such a fantastic facility available in the library. And it moved to its current location in 1925, and the Airdrie Astronomical Association, I believe, has been kind of running the observatory for us since around about 2010, I think it is, roughly about that.
That's correct, yeah.
And over the years, there has been some very famous visitors to the observatory as well, which includes 3 Apollo astronauts, which is very, very, very exciting stuff as well. So it's a great a little gem that is a part of our library service. And these guys that are with me in the podcast today are the kind of people who know probably most about it and certainly know more about astronomy than I do. So we'll kind of quiz them on some interesting things to do with the observatory and astronomy in general as well, and see what we come up with. So the last year, guys, it's probably been quite a difficult and frustrating year for you, not being able to use the observatory quite like you would have liked to have prior to COVID, I would guess.
Yeah, most certainly. It's been very, very challenging for the group, especially when we've got a lot of older members who are very keen not to circulate in society when we've got the COVID running about.
Yeah.
But we've managed to get a few Zoom meetings in, and we're started back up last week with some Zoom meetings. A lot of the members weren't too keen to meet back up in Wellwine Church that we meet in, which is obviously just next to the library. And sometimes we can go over from there into the observatory at night. But obviously for the last year and a half, that's not happened. So it's been quite a challenge there.
Yeah, and it's a shame really that that's been the case, because obviously it has been something that has been getting well used by yourselves in the group there, and not to be able to kind of carry that on has been a kind of real shame for us and for you guys. How has things been progressing with getting the observatory up and running to the point where we can kind of get back to kind of what it was like beforehand?
Yeah, well, we've had a few meetings and went over all the risk assessments that we need to do and all the method statements and methods of working, and we've got something in place. Unfortunately, we can't actually take people up to the observatory in person because access would be too difficult with all the touch points. Obviously, it's high up in the library, so we've got a large number of stairs to go up. And the space in the observatory is limited for the social distancing. But what we're managed to come up with is a remote viewing scope, which we're hoping to get set up starting on Tuesday evening. That's Tuesday the 30th, I think, 30th of November. And we will do a wee talk about the history of the observatory and answer any questions about astronomy in general to anyone that comes along. What we would say though is if anyone wants to come along, if they could email through the usual channels just to let us know that they're coming along. We will take people that will turn up, but you may have to wait to get in. We're hoping to do an hour session, and it'll be 3 20-minute talks within that hour. So if you come along, you might have to wait about 10-15 minutes to get into the next session that we'll be running. And if it's clear and we manage to get all the technical difficulties ironed out for the telescope, you'll be able to see what's in the sky from the actual observatory live, weather permitting, obviously.
And technology permitting as well.
Yes.
As you kind of briefly mentioned there, William, you guys did have previously meetings in the church next door, and those were kind of running quite regularly, weren't they, beforehand? And you got some kind of guest speakers and things like that come along to your meetings occasionally, don't you?
We've had quite a lot of quite distinguished guest speakers from all parts of the world. We recently, since we restarted, we've relied on our own membership to provide the meetings, but the one on the one after next is going to be from a chap who's been all over the place. He's been to Antarctica.
Wow.
He apparently hails from Galloway, so he's kind of local but travelled. He's going to be speaking about American star parties, whatever American star parties are. I imagine a bit like ours, except in America. But we have had, as you say, 3 Apollo astronauts. You can climb the stairs and stand at the spot where Charlie Duke autographed his image on the wall. People from Airdrie can actually stand where a man who stood on the moon stood without standing on the moon. We've put out an invitation to the new Royal Astronomer, the Scottish Astronomer Royal, a lady called Professor Catherine Haymans. She hasn't replied yet, but I think she's probably quite busy. She's the successor to a previous Astronomer Royal who unfortunately passed away. But he was one of the speakers we had, and so we get people come in from all over the place talking about all sorts of obviously astronomy-related subjects. And I will be quite honest, I've never heard a bad presentation. Some are more interesting than others because that's the nature of anything. But some of them have been really, really high quality. And occasionally we get the, not quite pyrotechnics, because I don't want to scare anybody think we're going to blow up the building. But actual demonstrations of things that make the science quite interesting. So yes, we've had plenty of famous speakers, and we hope to have plenty more.
Brilliant. And as you were saying as well, it's obviously since COVID that you've kind of moved that on a sort of digital platform now. So you're using Zoom, I think. Is that right, to kind of do some of these meetings now?
Yes.
Yeah. And are you still getting guest speakers to do that, or well, like you say, you were just kind of...
The one on the 17th of December will be the first of our guest speakers in this series. But an interesting comment somebody made to me was, see the people that were wanting in as guest speakers, they do it by Zoom anyway. Some of them are university lecturers, and that's how they operate their professional lives. So it shouldn't be a terrible hardship for them to come to our Zoom meetings and do what they do. So it's really, the difficult part is the hard work part is finding somebody to come and do talks, because people are busy and they've got other things to do, and we don't get out enough in the world to find out where they all are. So we're kind of relying on our own members to either come and do the talks themselves, or to say, I heard this very interesting talk from so-and-so, maybe you can contact them. So word of mouth matters a great deal in that respect. So we'll be getting more external speakers simply because we can, and nowadays it should be easy. We might even be able to get people who come on from foreign universities from their own countries, because there's no technological reason why they can't come and speak to us. It'll be the middle of the night in Australia or wherever they happen to be.
Yeah, that is the thing. That is one of the great things about the kind of using sort of Zoom meetings and things like that sort of stuff to do these things. It does widen the scope of people who can potentially get involved, and you can possibly get people from further afield who you would never necessarily been able to get, or would have been unavailable, that might kind of be able to say, yeah, I can do that, and kind of get involved with a kind of digital meeting. So it does kind of open up opportunities as well, so which is good.
As I mentioned earlier, when we do have guest speakers along on the Friday night, we always ask if they'd like to go up and see the observatory and give them a wee tour of it. And their travel arrangements permitting, they're always very keen to go up and have a look around it. And they all mention how what a great asset it is, and what a great asset North Lanarkshire have got for outreach to people, and not just in astronomy, but in science in general, and engineering, which we also cover at the observatory, because of the optics of the telescope and the actual engineering of it as well, which a lot of people find quite interesting, other than the astronomy, which is quite unusual.
Yeah, and it's a brilliant little hidden gem that we have, and from the kind of library point of view, it's amazing how many people come in and when you mention it to them, that they don't realise it's there, and it's great to kind of raise awareness that there is such a fantastic facility in Airdrie in North Lanarkshire, which is brilliant. So next up, we're going to I'm going to try and pretend to know a little bit about astronomy. William did help me out a little bit with this part by sending me some topic headers for potential things to kind of talk about. And the first thing we're going to touch on is the launch of the James Webb Space Telescope, which I had to Google the acronym that you sent along, William, for me to find that out. The astronomy world has been quite a bit excited about the forthcoming launch of the James Webb Space Telescope, which is happening next month in December. And I believe it's quite a kind of exciting time for the astronomy world, for that to go up into space, isn't it, William?
Yeah, it's been quite a journey for it. I think it was conceived in the 90s, if not before then, and they've been working on it for all this time. A lot of money and a lot of delays. But they're almost ready to go, and I'm not sure if it was in the news too much, but they were loading it onto the spacecraft, and a bracket failed, and it got a bit of a jolt. So it was delayed even further. It was supposed to be launching in the 18th, but they had to move it to the 22nd to check everything out. So fingers crossed and everything else crossed that it'll go up successfully, and it'll all be deployed. As I said, it's a lot of money to put in all your eggs in one basket, but the scientists are keen to see what it'll produce. Maybe Richard can highlight a wee bit of what it's destined to do.
Well, quite apart from the technical and mechanical and engineering challenges, which have been immense, because there's something like 340 potential failure points in its deployment. It's going to be doing something that we've never been able to do before. It's the replacement, essentially, for the Hubble Space Telescope. As William said, it was conceived actually in the 1990s, but the original proposal went in, and I think it was 1995, with a view to launching it in 2007. It has been delayed and delayed and delayed and delayed, and the costs have gone up and up and up and up. It's costing $9.8 billion. So thank you very much to the American taxpayer. But we've been patient about it. But it's what it's going to be able to see, because not only is it larger than the Hubble Space Telescope, it's able to see light in the infrared. The infrared light from stars doesn't really reach the surface of the Earth because of the atmosphere. And the Hubble Space Telescope doesn't have the instruments to observe in the infrared. But the infrared is where you'll see all sorts of things that we've never been able to see before, including, hopefully, we'll be able to see the earliest galaxies. When they were first formed 13-point-something billion years ago, potentially. We'll also be able to examine the atmospheres of exoplanets as those exoplanets pass across the front of their parent stars. We're hoping that we'll be able to detect enough of the starlight that will be able to tell us what the chemistry of the atmospheres of those exoplanets is, which is, I think, quite astonishing, because exoplanets were science fiction 10 years ago. And now they're kind of ordinary. We also hope to see stars being formed inside dust clouds, because infrared light passes through the dust clouds, the ordinary light doesn't. So we're hoping to see very young stars being formed, or even stars that are not yet stars being formed in these dust clouds, and sorts of things like that. And the point is that whenever we've set up new instruments to go and look at things, we've found things we didn't expect to see. So there are things that we hope we're going to see, but we've no idea what they are. so many things that are potentially just going to appear that we didn't expect. and we didn't predict. So it's going to really make a big change to our understanding of the universe and how it formed and how it's operating at the moment. And that's just a fraction of what it will be able to do.
Fantastic. I mean, I mean, being someone who doesn't know much about astronomy myself, I didn't realise it was such a long project that has been going on for quite so long. That's quite amazing. And I did hear about the delay that's kind of happened recently, then about the kind of and it just said an incident on the on the website that I found. So it's interesting to hear that it's a bracket that failed on it. So there you go. And I'm sure after all this time they won't mind kind of waiting just another few days to hopefully kind of get it sorted and up into space. So the other exciting thing that I saw recently in the news, which was it sounded all a bit Hollywoody for me to be kind of seeing, was the NASA Space Start mission, which sounds absolutely amazing, and which is basically that they're planning on launching a spacecraft into space, and they're actually going to, it's basically the first asteroid defense system mission, where they're going to basically crash it into an asteroid to hopefully knock it off course, and in case of obviously anything like that coming close to Earth. So have you guys heard any more about that? Like, you kind of shared a bit more kind of professional information about it than my explanation.
Yeah, it's a really interesting mission, and it's something that you see occasionally in the news regarding asteroids. In the astronomy circles, a number of years ago, probably in the 70s and 80s, asteroids were seen as a bit of a nuisance because they were small points of light that were whizzing about the sky that nobody could really be bothered about. But over the years, they were more and more discovered. So somebody thought, well, hang on a minute, all these things are whizzing about all round about us in various sizes. What's the chances of one of them hitting us? Because we get loads of meteorites hitting the Earth every day. Very, very small grains of dust. That's the shooting stars that you can see in the sky at night if you're fortunate to go out. And you see occasionally, I think the last major one was in Russia. And you've seen all the damage that did when it exploded over. And nowadays we have all these webcams and dash cams, and these pick all these surprise happenings and can show people what they're actually like. So with that in mind, the science community over the years have thought, well, if we find one and it's heading straight to the Earth, what are we going to do about it? How are we going to save mankind? So this has been a few years in the making, and it's testing out how we might be able to nudge an asteroid and redirect it away from the Earth. So we'll be sending up the probe, and it'll launch a small projectile, and it'll crash into not the asteroid, but a moon of the asteroid.
All right.
Because the asteroid it's going to is called now I'd written that down somewhere. I couldn't quite remember it. It's called Didymos, and the small moon around the asteroid is called Dimorphos, and it's actually going to hit Dimorphos, and they're going to measure the orbit of Dimorphos and see if it changes after it's been hit, so that they can find out if it is a possibility of changing the direction of an asteroid. Now, Didymos, the main asteroid, is 390 meters in diameter, and Dimorphos, the smaller moon of that, is 85 meters thereabouts in diameter. So it's quite small by astronomical standards. If Didymos hit the Earth, it would be probably quite a country-destroying event.
Wow.
If Dimorphos hit, it probably wouldn't be that too bad, depending on where it hit. and if it breaks up. The thing about asteroids is that there's two main kinds. There's very rocky ones and there's very metallic ones, which contain a lot of metal. And the metal ones present the most danger to the Earth because they tend not to break up. They tend to be more solid, and as they come in and heat up, they melt. Whereas rocky asteroids or meteorites tend to break up and disperse quite easily. So fortunately for us, metallic asteroids only make up about 20% of all asteroids. So the probability of meeting one of them is a lot less. And each asteroid is different, and that's what we've found. There's been a few missions out to asteroids, and we're learning more and more about them. They are basically from the early time of the solar system formation, so they're leftover bits from the primordial solar system. So scientists are very keen to find out a lot about them. So we've had a couple of sample return missions from asteroids which are coming back. The Japanese have done a lot in this to try and characterize what the asteroids are like. So there's been a couple of American missions as well, taking pictures and getting some samples back as well. Very small amounts of samples, must admit. The spacecraft just touched down, grab a couple, and float away again, and then hopefully bring that back to Earth. So they're due to arrive in the next 2 or 3 years. I think the Japanese one came back 6 months ago or something like that. So they got the results back from that. So the DART mission you're talking about, that's an acronym for Double Asteroid Redirect Test Mission. Right, so that's what the DART stands for. And on board there is a small cube satellite which has been provided by the Italian Space Agency. And what it's going to do is just before the impact, it will be let loose, and it'll actually photograph the impact and what happens after the impact. CubeSats are small satellites. You've probably seen them on the television and in the news. And they allow companies to have a satellite for a very low cost. They're about 200 millimeters square, something like that. And they can be launched in, and they have their own propulsion system and own wee cameras or sensors or whatever. They don't last very long. They don't have much propulsion, if any. But they are very, very low cost. And the space agencies have been using these a lot on missions as ride-alongs to the main mission that they can deploy. Sort of like a drone, if you like.
Yeah.
A small drone that can go out and see things from a different perspective. So the mission is very, very interesting, and it's going to be followed up in 2024 by a European Space Agency mission called Hera, which will visit the same asteroid again and see what the impact was like on the small moon Dimorphos, and check it to see what's happened 2 years after the impact. So there's a lot of effort going into this at the moment. So it's good to know that we're in safe hands and we're working towards a solution. The Planetary Society, based in America, they've been pushing a lot for this because they consider it's not a case of if it will happen, it's a case of when it will happen.
Yeah.
And the United Nations have actually got designated a day, the 30th of June, which is International Asteroid Day. And every year there's a series of events, month-long events, that people can view experts talking about it, and they raise the profile of this throughout the world to see what people are working on. So it's all it's all very good, and certainly keep your eyes on the news for it to see how it performs, because the pictures will be, I think, quite spectacular when they come back.
Yeah, I mean, it does. It certainly sounds like a fascinating mission for us to be kind of doing. And
put it into some perspective, Chris, just on to what William said, if you want to see what asteroids can do in terms of damage, because the point William made is it's a matter of time; it will certainly happen.
Yeah.
If you find out about the extinction of the dinosaurs 66 million years ago, that was probably an asteroid, and not even a particularly large one. It was about the size of a large mountain, the size of something like Everest, and it devastated life across the whole planet. And one arriving today would do exactly the same.
Exactly the same thing. Yeah.
They're trying to avoid that.
Yeah, and I mean, obviously there is no kind of way of kind of defence against that at the moment.
That's the point. This is the defence, because if you find it early enough, you only need to nudge it a tiny amount when it's far away for it to miss us, because we're actually a very small target in the space.
That's the thing. So I mean, when I talk about space, like obviously Earth seems such a big thing, but in terms of the space, well, it is pretty much a drop in the ocean. So it's like a kind of 1 in a million shot.
Yeah, well, to put it in, to give you an idea of the distances involved, the Moon is about 480,000 kilometres from Earth. The Didymos asteroid that the DART mission is going to is currently 485 million kilometres away.
Right.
So that's what, about 110 times? No, 100 times more, 100 times further away. And at the closest, when the actual impact happens, I think it's happening next year, the asteroid will be 11 million kilometres from Earth, and that's deemed as quite close.
Right.
So it's actually 5-6 times further away than the Moon is. So that's what all the space agencies deem as a close asteroid. They have managed to map all the orbits of all the ones that are close to the Earth down to, I think it's 1 meter in diameter, and they have a few. There's actually a website that you can go into and you can see how close they'll get, and they can work out their orbits, and they see how close they'll get to the Earth, and they can predict the orbit, get into the future, to see if it does pose a threat. And there is a couple that I think it was in the news recently that there was one Apophis asteroid, and it was confirmed that it wouldn't hit the Earth for the next 300 years. So that was so they've managed to. The issue that we have is every time they come near the Earth and the Moon interfere with their orbit. So that's nothing in the solar system is the same all the time. You know, things are moving, and the outer planets affect everything else that's going on round about. They can only predict so far into the future, but within the next 200-300 years, they've not found anything that would be of a great worry at the moment. But obviously, we've got to think of long term into the future, just in case.
Yeah, I mean, like the space telescope thing, it takes a long time for these things to be developed and kind of perfected and kind of ready to kind of go out and things. So so that's
the DART mission is actually, it's what they're terming they term it as a test mission as well, because they put a lot of new technologies onto it. And one of the most interesting things that I find interesting about it is the ion engine that they use on them, which sounds very sci-fi. But this is now they're trying out an ion engine that is 3 times the power of the previous ion engines that they've used in space, most of which have went to the asteroids. And an ion engine is a very, very efficient engine, but unfortunately it's not very strong. but it lasts a long time. So because space missions are so long, they can start up the engine and run it continually, and the small thrust that it gives over a long period of time means that it can change the spacecraft's velocity quite a lot. An ion engine, the ones that were launched initially, they've got the same thrust as you holding a piece of paper in your hand. So that's the force that they would generate. And the new one that's going out is 3 times that, so it's 3 sheets of paper in your hand. But as I said, they're very efficient, they're very fuel efficient, and they work by sending a gas out that's been electrostatically charged and between 2 electric plates, and then it throws it out at a very high velocity, and that creates the thrust. So they can take a small amount of fuel that lasts a long time, and it's good for doing missions that last a long time that you want to fly about in, but not good for getting anywhere fast, unfortunately.
Yeah, we need to be patient. We need to be patient for them to get there. So,
yeah,
fantastic. So, we'll kind of move on to our next little part of the podcast, which is going to be basically about the winter sky. So, obviously, we have reached winter, which brings about dark nights, and they polarize a lot of people. Some people like the dark nights, some people hate them. But I guess for astronomers, the dark nights must be quite a good thing to have, and must help you guys get longer time to kind of check out things in the sky and things.
Yeah, during the summer in Scotland, because it never quite gets dark at night during the summer, and if you get to midsummer, you can actually still read your newspaper at midnight, especially the further north you go, the easier that is to do. But for astronomy, that's pretty hopeless. I'm quite lucky because I'm one of my specialties, if that's the word, is solar astronomy. So that's better in the summer, gets you out in the sun. But and it's not so good in the winter. But the winter, the only downside of the winter is if it's clear enough to see things, it's also cold. So make sure you wrap up well if you're going to do it. But there's hundreds of things to see, absolutely hundreds of things to see, and will be. Well, personally, I'm looking forward to seeing some of the things that are coming along. One of the things that we always see when winter arrives, and it's when I regard winter as having appeared, is when you can see the 3 stars in Orion's belt. Then those are constellations will know what Orion's belt is. It's instantly recognisable, and you'll no doubt have seen it, although you might not know that it's Orion's belt. But it's 3 stars that basically are relatively close to each other, and they form a straight line. Mm-hmm. So when I see Orion's belt, I think it's winter, because that's the time you see it. The other things that we get to see, you just get longer to see things. You can start your observing earlier and do it for longer periods. Some of the things that you'll see in the winter, well, Orion's an example. You'll see Sirius as well, which is the brightest actual star. It's not a planet. And the 3 stars in Orion's belt point at Sirius, and Sirius is quite bright. In the planets this winter, aren't very good for observations because they're all just in the wrong place, unfortunately. But it's not like that every winter. It varies. One of the things I'm looking forward to is in the middle of December. I think it's the 13th and 14th of December. There's one of the regular meteor showers that we get. This one's called the Geminids, and it's called the Geminids because it appears to come from the constellation Gemini. It comes from that direction. Basically, when that's going on, people think meteor showers are going to look up and see hundreds and hundreds and hundreds. You don't. But the truth of it is, if you just lie down and look up at the sky for a couple of minutes, you're almost certainly going to see a shooting star. And when you've seen one, it doesn't make it boring when you see the second. They don't get less exciting. They're just something to see. They're a wee bit like William was talking about earlier, and they're usually the remnants of comet tails that we're passing through. And they're usually very tiny and they burn up in the atmosphere. But you do get sometimes ones that split up in the atmosphere, or ones that burn a slightly different colour. You even occasionally get ones that make a bang. They're very rare. I'm probably happy that they're very rare. I'm really quite looking forward to that. The other thing, but looking at the night sky, is the moon. The moon itself is a source of fascination for everybody. I'm sure everybody's at some time looked up the moon and went, wow, look at that. The full moon, I've got the date written down, it's the 19th of December is the full moon. But what people tend not to recognise is if Santa brings you a telescope, you don't want to look at the full moon through your telescope, because what you just get is the moon reflecting light almost straight back at you. What you want is the half moon. Technically it's called a quarter moon, but what you get then is the shadows created by the craters and the mountains being cast on the moon, and it makes it look much more three-dimensional, makes it much more interesting. So if Santa's been nice to you in bringing you a telescope, don't look at the full moon, look at the half moon, because it's just more interesting to see. The full moon's interesting as well, but it's better to see it that way.
There's a top tip for anyone who might be picking up a telescope for Christmas this year. There you go.
You can also see the moon through binoculars quite well. And binoculars are, people often say is, what should I get for the first telescope? And the answer generally is, don't get a first telescope, get a pair of binoculars. A, they're cheaper. B, if you decide you're not interested, you can use them for something else.
Yeah.
And the thing about it is, you can look at quite a lot of things and see them. You just see them better, because what the binoculars are for. There's a group of stars called the Pleiades, and the Pleiades is literally a genuine group of stars, and they're all relatively young stars, but they're very hot, which is why they're blue. And if you look at them with the naked eye, you probably would see, on a good night, you'll see 7 or 8 or 9. If you look at them with a pair of binoculars, you'll see 20 or 30 or 40. If you look at them with a good telescope, you'll see hundreds, because there's hundreds of them.
Wow.
And that's kind of the differences. But even as a naked eye object, on a clear night, the Pleiades are quite fascinating, because you can see the stars within. They look wispy because they're within the clouds. The other thing you can see with a naked eye, the furthest naked eye object on a very clear night, if you know where to look, is the Andromeda Galaxy. It's 200 million light years away, and it's a galaxy quite similar to ours, and it's apparently moving towards us, although some people dispute that. It might be moving away from us. But it's hard to go out there and check. But the light came from that 200 million years ago, before there were even dinosaurs. Yeah. So they're just fascinating things to see. But bear in mind, you don't need a telescope to do astronomy. Start with a naked eye and a wee map that says this is how you find the stars you're looking for.
Fantastic.
So that's where I would begin. So, but look out for the Geminids. Look out for the moon. The moon's always fun and fascinating. I will add that if you do get a telescope or binoculars, never, ever look at the sun directly through them, because it will permanently damage your eyesight, and you don't want that.
That's a big no-no. Even I know that one.
Good.
Well, have you got anything that you are looking forward to seeing this winter in the skies? Yeah.
Well, so if from Airdrie, if you get into an area where you can see the horizon, and if you look south, just after sunset, next week and the week after, you'll probably be able to pick up Venus very low in the sky just after sunset. So where you see the sun setting, it'll be, if you're looking at the sun setting, it would be slightly around to the left of that. You should see a bright star near the horizon, and that'll be Venus. And then if you go up from that about 45 degrees, 30 degrees angle, you come to Saturn. And then if you go up a wee bit further, you'll come to Jupiter. So you should see, if you look in that general direction after sunset, south, southwest, they're both of them are quite low in the sky at the moment. Jupiter's quite high, but there are 3 bright objects in the sky, and there's not much at that time. Just after sunset, about half an hour after sunset, there's not a lot of stars that are out at that time. You will see those will stand out, and that's one we get most questions asked about is Venus. It's quite low now, so it's not as bright as it would be normally, but it's the third brightest object in the sky usually. So that's quite. You'll notice if you look at them, you'll notice that they don't twinkle, and that's what gives them away from a normal star, because they're not actually points of light. They're actually they've actually got an area. If you look through a pair of binoculars, you should be able to see the disk of Jupiter, and might catch the phases of Venus. You might see it as a crescent, because it's obviously nearer the sun than us. And Jupiter, Saturn, you might through a pair of binoculars, you might see that it's not quite round. You might see the the sort of rings sticking out the side.
Yeah.
But a telescope will show all these quite clearly, and you'll see the moons of Jupiter, even if you've got a small telescope. So that's they won't be around much longer. As we head into winter, Venus will set earlier and earlier, and probably in the next 2 or 3 weeks, it'll disappear below the horizon, and then Saturn will follow it, and then Jupiter. But for the next 3 or 4 weeks, you should be able to pick them up.
Should be able to catch them
in the south, weather permitting, obviously.
Yeah.
So half an hour or so after sunset, if you go out and have a look, you should see them. So that they're quite interesting to have a look at, even with the naked eye, especially when they're so close and you see them in the field of view. They do look quite impressive. And it's I was out in the park the other day there, and there was a family, and they were a bit in front of me, and I noticed the teenage daughter. She looked up and she started pointing, because the three of them were quite clear, and she was obviously asking her parents what they were. I don't know whether they answered them right enough. They were too far on, but for me to catch up. Yeah, so people are when you look up, it's quite interesting. Certainly get out, try and get away from streetlights. That's another thing. So the things that Richard were mentioning there, the darker the sky, the more you'll see. And the Andromeda galaxy is, if you get a dark enough sky and you get your eyes adjusted to the dark, then it can look quite spectacular. You can notice this fuzz, and once it's pointed out to you, you go, oh yeah, I see that. So that's quite interesting.
Fantastic. Yeah, I mean, when you do get to kind of see kind of the stars in the sky and things like that, it can be quite spectacular to see, just like from the naked eye, and kind of, it would be fantastic to see them a bit closer up. And if that teenage girl that you saw in the park happens to be listening, there you go. You've got an explanation for it. If your mum and dad couldn't tell you what it was, so hopefully that explains it.
A wee thing about Venus, just before you move on, and it won't happen. It isn't happening now. But sometimes it's bright enough that you can see it during the day.
All right.
And it just appears a tiny wee white dot in whichever part of the sky it needs to be at. Because I remember once when I was at school that happened. Venus was very bright, and the police were getting phone calls about there's weird flying objects. No, that's Venus, and things like that. But this particular day I was in physics as it happened, and I looked out the window, and because it wasn't very interesting, and thought, what's that? And I realised it was Venus. And I get into trouble with the teacher going, what are you staring at is Venus. It can't be Venus. Can't see Venus in daylight. Yes, you can. And the whole class is, well, I can't see it. It's there. And it must be, it's not moving. So it's not an aeroplane. So it occasionally does do that. This, unfortunately, isn't one of those times. But Venus is fascinating as well for a whole set of other reasons.
Fantastic. So the next thing that I thought we would touch on a little bit was that there has been recently quite a lot of solar storms in the sky, which has led to the auroras and things in the sky as well, which has been visible from Scotland, hasn't it?
It would have been visible from Scotland. It would have been visible from Scotland if you could get rid of the clouds. Scotland is always the clouds, as Williams several times said, weather permitting. We're in the process of entering into what's called the solar maximum. The sun goes through cycles approximately 11 years long, where the number of sunspots and the activity on the surface increases and decreases. So it's been very quiet for the last wee while, and it's now probably about a year or so into the next solar maximum. So there have been more sunspots. There are more things to see going on round about the sun. But what we got in October was something just a wee bit special. What we saw were two things. There were some solar flares. Now, solar flares are radiation. They're gamma rays and X-rays. And they travel, as gamma rays and X-rays do, they travel at the speed of light. So they arrive on the Earth about 8.5 minutes after they leave the sun. They're not dangerous to the people on the surface, because the atmosphere screens them out, but they are dangerous to people on the space station or if we ever have them on the moon. or just up in space where they don't have the atmosphere to protect them. But solar flares are sometimes accompanied by something called a coronal mass ejection. Not a very easy name, doesn't exactly roll off the tongue. So we call them a CME, and a CME is a mass of billions of tons of charged particles, protons and electrons, and they don't travel at the speed of light, so they take 2 or 3 days to arrive here. But they pose a serious risk to electronics, particularly up in space where there's no atmosphere to stop them, or more exactly, the magnetic field protects us from them. But they can fry your computer, and you might not realise this, but they can fry the computer that starts your car, because when you turn the ignition in your car, it doesn't actually tell the engine, it tells the computer to tell the engine.
Yeah.
So a very serious one could cause really very major problems for us. There was an event, I think in the 1980s, where a large part of Canada was blacked out by a solar storm, because the electricity infrastructure was basically fried for several days, because this happened. But the nice thing we get to see is the aurora, if the weather lets you. What the aurora is, is essentially these charged particles. They are caused by the magnetic field to divert to the poles, the north and south pole. So there's the aurora borealis in the north and the aurora australis in the south. And these charged particles then collide with oxygen and nitrogen atoms in the atmosphere, the upper atmosphere, and that causes these atoms to emit light. The main colour is green, and that's when they react with the oxygen. But there's also red and blues and sometimes purples and other colours as well. I've never seen an aurora, and it's very firmly on my bucket list. And hopefully my wife will listen to this, and maybe that's what I'm going to get for a present in some birthday in the future. But the aspect that you see, you maybe be familiar with the song "The Northern Lights of Old Aberdeen." That basically is a story of somebody's able to tell you at the time they saw the Northern Lights at Aberdeen. It does happen. It isn't very common. This time, the Northern Lights were apparently visible at latitudes as far south as Stirling, and maybe even further south. But unfortunately, the weather was just, grey, as it usually is. But nevertheless, they're very interesting auroras. And now that we know what causes them, it kind of makes my head spin just a wee bit that this is going on over there and it's causing this to happen over here.
Yeah, it's fantastic. I mean, I think most people have probably seen it at least on like kind of TV or video footage or whatever, and it is very spectacular to see. And I think to kind of see that in person would be just a kind of even more special again. And it's just a kind of one of those natural phenomenons that kind of blows your mind a little bit how kind of fascinating it can be. So we should definitely kind of watch out for them hopefully happening at some point again in the future whenever we get a clear sky, maybe if we're very, very lucky. So you never know. Now guys, this is usually a book podcast, so I'm not going to let you guys escape without talking a little bit about books as well. And so as much as it's fun about talking about our very historic observatory, let's see what you guys have been reading as well. And feel free to talk about books as well that are astronomy related to as well, because those are books too, if it happens to be, or if it is any kind of normal fiction books or whatever, feel free to talk about them. So, William, what pages have you been turning recently?
Well, I've because of my interest in the asteroids and the meteorites, I read a book which was just released called Meteorite, and it was written by a guy called Tim Gregory, and it's an excellent book. He's a science communicator. I think he's actually a chemist by profession, and he works. I think he works down in the nuclear reactor down at Sellafield.
Okay.
He's been on a number of programs, as a science communicator, and he's written the book about meteorites. And as I mentioned before, these come mostly from asteroids. We get the ones from the comets, But his book also extends into why we do science and the benefits that come out of doing pure science. Things that people might not necessarily think of being useful for humanity. It doesn't result in a new phone or something like that.
Yeah.
But he's got a lot of examples of where pure science led to quite remarkable finds, all in relation to scientists studying meteorites and asteroids and trying to find out more about them and analysing them. And it's certainly, I would recommend it, and it's not a scientific read. Anyone would be able to understand it, and I certainly learned a few things from it. One of the questions, I'll not tell you the answer to it, but if you actually think about how do they know how old things are in the solar system, it explains that very well. And if you think about that, how do we know how old the solar system is, and how bits, when you hear, well, the moon is X billion years old and Mars is Y billion years old, how do they know that? And explains it all very well. So that's one to have a wee look at if you're wanting to broaden your understanding of that. And one of the other ones I listened to was reading. It's a very geeky book, but there's a lot of people that write about the space missions, and I'm reading one about the engineering of the Mars Curiosity rover, and it's by Emily Lakdawala, an American author. She worked for the Planetary Society for a while, and she's done a lot of books for education as well, but it's more of a geeky book, and it goes into the actual engineering of the Mars rover and everything that went into that. Not for a light read, but certainly very interesting. And I think there's a wee bit of the politics in it as well, as to how these missions get off the ground and funded and things like that. So it's all quite interesting to see that.
Sounds good.
Yeah.
Fantastic. And what about yourself, Richard?
Well, I've got a couple of books as well. The first of them is a book called 16 Million Degrees by Professor Lucy Green. Professor Lucy Green is a professional astronomer. She occasionally appears on programmes like The Sky at Night and Horizon. And her area of speciality is the sun. And the title 16 million degrees refers to the temperature at the centre of the sun. Okay. I've got to say, this is one of these books where I thought, I don't know if I'll like this, but I turned about 3 pages, but I thought, yeah, this is good. And it's not a difficult read. She's actually quite good at communicating the science. Yeah. Must say, incidentally, I find it fascinating with science communicators, but we never have arts communicators. Must be a reason for that. But anyway, she basically tells the story about how the sun does what it does from the centre out. Describes things that are not visible, but they are obvious to people with the correct equipment to do, and how the sun has its various layers and what the various layers do and how they interact. The most stunning fact I got from it was that a photon that's created in the centre of the sun that's travelling at the speed of light takes 180,000 years to leave the sun. Because it's so dense, it's just interacting with things all the time before it can actually leave. The average time is 180,000 years. She also mentions a US alternative rock band called They Might Be Giants. Don't know if you ever heard about them, but they recorded a song called Why the Sun Shines, and it said the sun is a ball, the sun is a massive incandescent gas. And people went, that's not correct. And they said, okay, sorry, tell us what is correct then. So they re-recorded a version called How the Sun Really Shines. And the words are, the sun is a magma of incandescent plasma. So that's much more accurate, but it suggests to me that scientists aren't really geeks. If they're listening to They Might Be Giants. So that was the first book. I strongly recommend that one. I've got a hard copy somewhere. that I think I took on holiday with me. It was probably in the loft in the suitcase, and it was so interesting that I got a Kindle version and read that. So it's one of the few books I've read twice. The second book is the Cosmic Revolutionaries Handbook, it's called, and this is by two Australian astronomers called Luke A. Barnes and Geraint F. Lewis. And the Cosmic Revolutionaries Handbook is basically a challenge to anybody who says Big Bang can't be right. Because what the book does is it explains why the astronomy world thinks the Big Bang is probably an excellent explanation, although not necessarily a perfect one. They challenge all the alternative theories and tell you why they can't work, how they don't match observation. And they even tell us ways in which the Big Bang theory might be wrong. For instance, there's something called the lithium problem. I didn't know there was a lithium problem, but there's a lithium problem, and they describe it and why that's not been solved. So even for people who are not convinced by the Big Bang theory, it gives them an opportunity to say, well, I've got a better idea. So if they have a better idea, here are the things that you need to overcome in order to make your idea acceptable. That's really the basis of the book. But again, it's not a difficult read. It does get a wee bit technical sometimes because of the nature of the subject, but they avoid, I'm glad to say, mathematical aspects, because that always throws me off. Maths just makes me bored. It's not that I can't do maths. I just go, oh, that's maths. Keep it away. But they're both quite good authors. They've told a very interesting and convincing story, and they do take into account the alternatives that other people might seriously propose. They don't go with the world as a disc supported by elephants standing on a big giant turtle. That's the kind of thing they can't do. So you need to be scientific, but if you want to try to shoot down the Big Bang theory, go to that book.
Fantastic. That's some fantastic, really good recommendations there for some scientific books. And thank you very much, guys. That's the end of my questions, really, for you guys. So it's been really great insight into astronomy and getting some background into some of the kind of big things that are happening in the science world, and your kind of experience of using the observatory as well. So thank you very much for that, guys. Just before we finish up, I'll give you a little bit of a rundown on some of the things that are happening with the library service in the near future. And the big thing that's really coming up for us is Winterfest, which I think you guys are kind of involved in. I think you guys are coming along to Winterfest.
We're turning up with, we'll refer to it as a stall, but I'm not sure that's quite the right word. Partly depending on the weather. We're hoping that we'll have some things to show people. But the point about it is the last time we did anything like that, when I attended, the number of people who came and said, I didn't know there was an observatory in Airdrie, is just astonishing. So we'll be there on the 4th.
Fantastic. So it's on Saturday the 4th of December. It's going to be at Summerlee, and the library service have arranged various activities to go on at the museum. There will be a couple of authors appearing, David McPhail, a children's author, and a local author called David McClure. And also, if you like dogs, there are also going to be therapets there as well, which you can come along and see the lovely therapets dogs as well. And of course, the lovely guys from the Airdrie Astronomical Association as well, amongst loads of various other things. Because it is at Summerlee, you do need to book a ticket to either go to Summerlee or to book for one of the bookable events as well to get access. So you can do that on the website, and you can find all the information about it at www.culturenl.co.uk/winterfest. So you'll find out everything there you need to know to get into the museum. And that's pretty much all for now, guys, for us. If you have enjoyed this podcast, do leave us some feedback on our hashtag FLB podcast, or by dropping us a little email at librarypodcast@northland.co.uk, and we'll be back again soon for another episode. So thank you for listening. Bye, guys.